No, there's at least
Oh,
9
there
of
we
them, I
are.
think.
We have them. There they are. Maybe we should get a second screen over there so we can, see the Zoom part and what's going on. That might be interesting. All right. And, you can keep the telescopes as long as somebody doesn't want them. And we've had some people kept them for 3 months. It's a way to test out, do you A, want a telescope of your own? What kind do you want? Because we have refractors, reflectors, Dobsonians, equatorial mounts. And I'm going to ask some people, if people want to get into astrophotography, if you those telescopes are good for that. I have a couple of, older, less expensive cameras. I'll loan it to somebody and they can play around with it, see if they do well or not. All right, so keep that in mind that we're getting into this part of the year where we're having more clear weather. Yay! I'll tell you, and I'm hoping we're also going to have very clear weather on the Dark Sky Festival. And Bruce, can you guarantee that? Okay, Bruce has put in a guarantee. Great. All right. So with that, I'm going to turn it over to Rocky, who's our program chairman, and he can introduce the speakers, which will include himself. And I hope we have a very good meeting.
Hit it on the wrong side. Yeah, I can hear myself now. So, that looks pretty good. Um, so tonight's constellation of the month, and we used to have these all the time. It's been a while since we've had one, but it's Cygnus, and I I picked it out because I like it, but I was amazed when I got into it how much stuff there is in Cygnus. It's a pretty fascinating constellation. This card is from, you're right, is a historical card. It's from 1825. You're right, it was a set of cards, and this is the way you used to have to learn the stars. And our our star maps are a lot different from these now. They're not nearly as artistic. They were pieces of art back then, but I always like these. So, okay, I wonder if this thing's on. Sorry, Sean. Well, I tried it too, and it didn't work either. Oh, okay, that works. Okay, so Cygnus the swan. Cygnus is Latin for swan. Wait a minute, I've got a cheat sheet over here I need to get out. And it dates back to Ptolemy. its original 48 constellations, and of course, it's part of the 88 constellations that are officially recognized today. So, but it dates back way before that too. I couldn't find any other information on it. But the Greek legend for it, and there's legends from all civilizations, but I'm just going to talk about the Greek ones. Cygnus and Phaethon, when Phaethon, I guess, the son of Apollo, when he drove his chariot too close to the sun, Cygnus was his good friend, and he dove into the river to try to find Cygnus's body. Phaeton's body, and Zeus was amazed at his loyalty and turned and put Cygnus into the sky. The other one is about Cygnus and Leda, and Zeus took the form of a swan to win the love of Leda, who was the wife of a Spartan king. And yeah, he was going after other men's wives, I guess. But anyway, Leda was the mother of Helen of Troy and Castor and Pollux. And anyway, I don't know if any of y'all were fans of Orphan Black, but I was, and that had Leda and the swans in it too. Orphan Black, yeah. Oh, Cygnus is part of the summer triangle, and the summer triangle is visible May through December. And actually, this time of year, it seems to stand still because every night it gets dark 4 minutes earlier. And so Cygnus is just right up overhead, and it'll be there for a month or so, it seems like. And it goes pretty slow down until after Christmas. But you'll be able to see Deneb, which is the tail of Cygnus, on into and Cygnus on into January. So they stay up a long time. But Deneb is the part of the summer triangle, is the Demis star in the summer triangle, and which is Vega, Altair, and Deneb, and it sits within a portion of the Milky Way, as you see here. And the Great Rift goes through Cygnus, and these red marks down here. John had a really good thing on Facebook of this area of the Milky Way, I think, and he had more red. But these red are star producing, where stars are being made. Thanks. You figured it out. Oh, and this is just a diagram of the area around the summer triangle and the summer triangle. And one thing I want to point out is is the Northern Cross, and it's the brightest part of Cygnus. It's the center part of. Let's see, I can do this here. Is this so? This is the Northern Cross, and it's pretty visible before you see the swan. Then you add a couple of stars to it to make it look like a swan. You know, a lot of constellations don't look like what they're named after, but Cygnus actually does. And I like to think of it as, and you've got Cygnus and Aquila here, and they're both flying down the Milky Way. If you're out there where you can see the Milky Way, you can imagine that they're both flying right down the Milky Way. Aquila actually looks more like an airplane, but it makes a pretty good bird. Okay. I want to talk about celestial objects now that are in Cygnus, and there's a lot of them. This map is from Skalnate Plaso Atlas, which was my first good my first good atlas was Norton's, but I always thought this one was very pretty. It kind of from like the late 50s, I think. But these green areas that you see on it are the star producing regions. So there's a lot of stellar nurseries in Cygnus, and we'll look now at star clusters in there, nebula, galaxies, and there's the very first black hole was in Cygnus. And Michael pointed this out to me. The skilive.com shows all the objects in Cygnus, and there's 85 different objects listed in it. So there's a lot in Cygnus. There's open clusters, two Messier objects, Messier 29 and Messier 39. Messier 29 is known as the cooling tower cluster. I'm not sure where it got, somebody gave it that name. It's magnitude 9 and size 7 minutes in diameter. Messier 39 is mag 5.5, so it's the naked eye if you're in real dark skies, and it's bigger. It's not as distinct to me as M29, and you can see them in the blue circles there. X Sig X was the first X-ray source found, and it was discovered in 1964 during a rocket flight. First black hole found that they figured out was a black hole. And then there's a really pretty galaxy, and I got pictures of it here in a minute. In Cygnus, is actually on the border of Cygnus and Cepheus up here at the top, and that is the fireworks galaxy. And this is just pictures of M29, the cooling tower cluster, and M39. And you can see M39 is not as distinctive, but they're both easy binocular objects or telescope objects. And this is the fireworks galaxy. I asked for people to send me some of. We've got great astrophotographers in here, and I asked some of them to send me some of their images, and so I think I don't know. I think astrophotography, one of the lures of it is it's almost like art. I mean, you can kind of change your colors and stuff like that and make them more saturated. But then this one's really pretty. This is Danny Flippo's with the star colors are just really pretty in it. He's about to. I think I've got one of his from 2011, so in here. So he's been in it a long time. Okay. This is another one by Michael Borrelli, and that was last year, and that's the start of fireworks galaxy. And I got a little something on the fireworks galaxy here. It's Mag 9, and it's 10 million light years away, so it's pretty close. You know, Andromeda is 2 million. It's very active with 9 supernova observed, so it's aptly named the fireworks galaxy. And that's more than any other galaxy. M61 and M83, I think they're both in Coma Berenices or Virgo, have 6 each. And it also has a high formation rate of new stars, so it is aptly named fireworks galaxy. Okay. And then here's some more that we'll be looking at is there's the Cocoon Nebula, the North American Nebula, and it kind of shows the location and this is a astronomical union chart right here. So I'm showing you some different charts. And then down here at the bottom is the Veil Nebula that a lot of people take. That's one of the very popular object to take pictures of, and it's not easy, is it? Because it's so big. Yeah, it's huge. And the other one is the Crescent Nebula. Okay, and this is Jim Dixon's Crescent Nebula, and he opted. A lot of people opt to leave the stars out, and that's just one artful way to show it. That's got a lot of detail in it. Okay, and this is Danny's, and it's with a 10-inch Newtonian, and so the bigger scope, you expect to get more detail, and he's got some blue wisps around it. Really nice. This is mine. I actually did this a week or two ago, and I took out too much, I think, but anyway. And this is Michael's Borrelli's, and that's with the 8-inch. Mine was with the 6-inch Newtonian. Okay. And this is a North American nebula, Jim Dixon's. And I like this one. This one's not quite starless, but it's almost starless. With a C11 hyperstar. Okay. And this is another version of it by John Reed. And this includes the Pelican Nebula also. And you can see the North American Nebula right here. Okay. John, I messed with your image a little bit. I turned it right side up so I could tell it. So it made it a little bit smaller. But anyway, this is another of the North American Nebula. Okay. And this is Danny's version with the Pelican Nebula in blue color. And this is the Veil Nebula by John Reed, Stellar View SV90T, which is that 90 millimeter. Is that what that stands for? 90 millimeter. Yeah. Anyway, this shows was that a mosaic? Because I wouldn't think you could get both sides of it in there. Okay. And Jim Dixon's, and that's with a lens and a camera, which is a nice way to do it. And Michael's, this is the Western Veil Nebula and the Eastern Veil Nebula. I like your star that you said you had such a problem with. I think that makes it really nice. Okay. And this is Danny's Veil Nebula with a Red Cat 71 and a 2600 MC Pro. Okay. Oh, and this is really interesting. And I couldn't even find where it is. I didn't spend a lot of time, but supernova remnant in Cygnus, and this is very big. This is I put the approximate size of the full moon on here, so that's how big it is. Here's down here at the bottom is the approximate size of the full moon, and so you can. Okay, yeah. So it's about 6 times wider than the full moon, or something like that, 5 or 6 times wider. And this is the Cocoon Nebula. Cocoon Nebula is a star nursery, like the Orion Nebula or the Lagoon Nebula. And that's Danny's. This is one I took a week or two ago with mine. Oh, and this is one that Michael added, the Tulip Nebula, and I modified it a little bit. I cropped it and turned it right side up so I could see the tulip. And Bruce is going to be talking about variable stars, but my favorite variable star is in Cygnus, and you can see it blinking right here, and that's over about a 7 to 8 week period. It'll go from magnitude 12 up to magnitude 8 for 2 or 3 days or something like that. So I used to look at it almost every night I could, just to see if I could catch it in outburst, and I did several times. Also, and I forgot to wear my pen tonight, but the Variable Star Club pen, if you can see here, it's the same. That's what it's got on it, is SS Cygnus, and that little triangle there, which makes it easy to figure out what magnitude it is, because there's a star. I don't remember which stars it is, but there's a star that's right about magnitude. These stars are kind of stair step down to magnitude, from magnitude 8 to magnitude 12. So it's pretty easy to pick it out. Okay. Right. Yeah, that's why I did that. Okay. I think, and one thing I didn't talk about Deneb enough. Deneb means tail in Arabic, and almost all a lot of your star names are Arabic, while your constellation names are Latin. And Deneb means tail in Arabic, and there's 4 or 5 other stars that have Deneb in there. Denebola, Deneb Katos. There's several other stars that have Deneb in their name because they're tails of the constellation, or something somebody thought was the tail. But the Neb is the brightest star, farthest star we can see. One of the farthest stars. It's by far the farthest first magnitude star. It's 2,600 light. It's like the 16th brightest star, and it's 2,600 light years away. It's also it's a white supergiant. It's about 200,000 times more luminous than the sun, and it's short lived. Only 10 to 12 million years. It's only 10 to 12 million years old, and so you think about our sun. Our sun, I think, is like 4.5 billion years old. So 10, 12 million years old goes back. I mean, we can pinpoint a lot of things that happened in the last 10 or 12 million years. That's right, because that was 60 million years ago. That's right. Um, oh, they also predict that it'll be a supernova one of these days because of the type star it is, and it's burning through its gases so fast. The next one down here, and that's the head of the swan. And if you've never seen it through a telescope, you need to make sure you look at it sometime. It's one of the prettiest stars out there. It's a blue and yellow. I ask people what colors they see when they look at it at a star party, and they'll range from different colors, but some of them will get blue and yellow. And blue and yellow is blue would be the hotter star, and yellow the cooler star, and then red would be even cooler than that. 61 Cygnus is a binocular double, and what's interesting about it is it's only 11.4 light years away. It's the 12th closest star system. It was named the Flying Star, and this is pretty amazing to me how these guys could figure this out. But in 1792, Giuseppe Piazzi named this the Flying Star because it had large proper motion, because he could tell it was moving within the stars. So they had a lot of abilities to pinpoint objects where they were in the sky, and then look at them years later and see. It's also a nice double to look at in the scope or binoculars because of its orange-red colors. In 1838, it was the first star to have distance estimated by parallax by Frederick Bessy. So that's important. And then and he guessed that it was 10.4 light years, and it's actual about 11.4 light years. So that was back in 1838 that he did that. Another important star is P Sig in Cygnus, and I tried looking that up on Sky Safari, and it didn't have it, but it had 30. It's known as 34 Cygnus. The reason it's named P Cygnus is in 1600, Bayer made his charts up, and he named the stars Alpha, Beta, Gamma, and then after that he named them by letters. And so this star was in nova at that time up to about third magnitude, and so so he named it a P, and then it went down later. It's been between third and sixth magnitude ever since 1600, and it still varies. It's a luminous blue variable star, mag 4.8, and about 6,000 light years away. It's the farthest star that we can see with a naked eye, 6,000 light years away. massive star destined for supernova. It was a it was a second this goes along with Bruce's. It was the second variable star discovered after Mira. That leaves out Algol, because Algol was discovered a long time ago before that. But it's not a variable star, it's a binary star. You're right. Okay, next one. I've just got two more. And right now is at the Dark Sky Fest last year was some of the best skies I've ever seen. And one reason was the time of year. And you got the summer triangle and go on to the next one. But the star of the show was this area right here, was Scorpius. Scorpius was laying down on the horizon or close to it, and then Sagittarius right behind it. And you got all these beautiful deep sky objects right above it to look at with telescopes. Plus you've got the Milky Way coming right out of it up through Scutum and Aquila and on up in through thing. So if you don't start learning your constellations if you don't already know them, because this is the best, to me, this is the best time of year to be looking. That's all.
Okay, thank you. We have a long overdue award. It's a club award. If you didn't know that we have club awards, this is the Skywatcher Award. It has a basic and a full level, and this is the first person I know who has completed this, Ken McLeod. Oh, selfie. Let's see. Thank you, Rocky. There, hold up your award. I'll send that to you. Thank you. It is. It's a beginning level course that has a wide variety of not difficult things to do, but they lead you into the rest of all of the studies that are possible. And I want to ask, how many of you seen the movie Apollo 13 Survival? Yes, this is different from Ron Howard's. This is an actual documentary that's been stitched together. It's It's a very well done. And on the first part of the movie, you're going to see them laying out some pictures when they were planning where the landing sites would be. And I have some pictures. And I need to read you the caption. John, would you hold one of these up for me, please, sir? It says, a couple years ago when we were at Alcon in Baton Rouge, we met some folks from the Corpus Christi Astronomy Club. And he told me, I recorded this, what he said. These images are the original lunar orbiter missions 2 through 5 from 1960s. How many of you were born after 1960? All right, this is history for you. Okay, they had a camera on the satellite with them on the spool. They would develop the film on the satellite, then send it back to the Earth, and or kind of like faxing. I'm not sure the technology back to NASA on the Earth, line by line, line by line. See all these little things. They assembled it, produced images which were used by the researchers, geologists, scientists that were scouting for the landing sites for the Apollo landing missions, for the manned missions to the moon. These have significant space history that the Lunar Planetary Institute was just going to throw these away. So their astronomy club went to Houston and acquired them. It said they gave some to a university that they wanted to keep for their archive. He said he had a lot left over that he brought for the people at this convention. That's what these are. These are the images the researchers used to scout those landing sites. That's and in the movie, when you watch this and you want to watch it, they have a couple of maps laid out, and it has some of these with the lines, and I have 4 of these, but I'll have them up here that y'all can look at. This is history right here. These are originals. Yes. Yes. And tonight is International Observe the Moon night. So with the clouds, this is as close as we're going to get to observing. Okay, yay.
Yes. Yeah. Okay, so some years ago, I gave a little talk on variable star observing. I was sort of hoping to stimulate a few people to do a little bit of it. I wasn't successful. So I thought the time had come to try again. What was I? Well, I didn't know that. Okay, now he says he did too. Oh, all right. So another try. Maybe we'll get some more. Before we get into variable stars, I just wanted to back up a little bit and have us think about just how fundamental stars are in general. Think about a universe in which there was no fusion, just a great void with some hydrogen in it that had no ability to do anything, just clump up. Everything's dark matter. Stars are everything. Stars light the universe. Stars make all the matter denser than hydrogen. On this planet, star fuels life, and it's hard to imagine that you could have life without a star. Stars are it. And so anything that deals with stars has fundamental significance. Now, this thing is not working again. It's eating batteries, I guess. Huh? Oh. So what, huh? Did it get turned off? Those batteries I just put in are pretty old. Here, how do I do it here? No sense in, okay. What? Well, that's going to be clumsy. Now, our distant ancestors intuitively understood all this. They were the earliest astronomers, and all of them amateurs. But they, as you go back as far as we can go in any kind of record, humanity, wherever you found them, viewed the cosmos, the starry night, as a source of creation in the realm of the gods. They understood that the sun gave the life energy. It was a source of energy. They understood that. And they were students of the stellar motion, the night sky. So much so that they could use it as a clock, calendar, compass, and I like to say Netflix, because they hung the stories of their heroes, their villains, and their gods. Their culture was defined by the patterns they saw in the stars. And now it turns out that these cave paintings that go back 30, 40,000 years turn out they're not just random pictures, drawings of people and animals. They're constellations. All that way back. I wish there was a way just to hit a key here. There we go. Great. So, make sure I didn't. Yeah. So in our talk here, we're going to, what am I doing? With my right hand. Yeah, how do I back out of it? John? Huh? Oh, is that where it is? Poor Sean. At least. All right. So briefly, we're going to, in this little talk, we're going to learn how variable stars triggered a renaissance in astronomy. We're going to learn how variable stars and the observation and study of variable stars birthed the first and one of the most robust, if not the most robust, citizen science organization that exists, the American Association of Variable Star Observers. We're going to touch on why we study variable stars. And finally, I hope, the real meat of the nut, which will actually be pretty brief, who can and how to become an amateur variable star observer. Now, we'll dispense very quickly with the why observe variable stars. I already touched on how important stars are, right? But beyond that, variable stars in particular have been the sort of the original accelerator, in this natural accelerator in the sky, because understanding variable stars and what makes them happen gets you inherently into the physics of the atom. And so they're natural laboratories. They are the means by when one of the principal means for measuring interstellar distances, still used, still an important element there. They are an insight into stellar life cycle and evolution. We can't watch a star through its whole life cycle, but we can catch individual stars. That's largely what makes variable stars. A big part of it is where they are in their life cycle. So by studying variable stars, we can come to understand the life cycle of stars. And finally, in these days, it's a potential source for exploring the potential for extraterrestrial life. And that's with the transits, planetary transits. Now, this is a mechanism dated around 100 to 200 BC, the Antikytherian mechanism. Did I pronounce that reasonably well? This was discovered on the bottom of the Mediterranean. It's an extremely intricate brass geared device to predict the motion of the planets, the moons, and the stars. Huh? So what? Our time travel device. Well, whatever. The fact that they had the ability back then to machine this device was amazing. But I bring it up because this sort of represents a point in time in which astronomy comes to a dead end. After this period of time, humanity had studied the motion of the skies well enough that they could predict these things with reasonable accuracy. They didn't understand why the planets did what they did. They only knew how to predict it. But Ptolemy had cataloged the brightest stars, the constellations he had charted. They had this kind of knowledge about predicting the motions, but what else could you do? With their technology, you couldn't do anything. And so for the next 1,500 years, astronomy just stagnates, at least in the Western world, as a practical matter. Almost nothing happens. And in fact, the astronomical point of view, when we jump forward where we're going to the 16th century, was that the universe, we knew everything you could know about the universe from the Bible and Aristotle and Ptolemy. That was it. And if you were interested in astronomy, what you did is you studied those theories and read the Bible, and that the universe was immutable, never changing. And that was the view, and then that was the view, was one reason astronomy was going nowhere. Until this gentleman comes along, Tycho Brahe, 1572. Now, Tycho is an interesting character. He was an upper middle class, probably maybe you could say a little better than that kid, and his dad sent him off to university to become a lawyer. You know, worthy occupation. There were some big astronomical events that were sort of buzzing around, an anticipated eclipse. As I recall right, I should have looked this back up to refresh my memory. And maybe a lunar transit or something like that. And he noticed they just weren't that accurate. And he became obsessed. And he became a professional astronomer. And one of the early concepts of a professional astronomer was Tycho Brahe, unless you count the priests from way back when, the astrologies. But he dedicated his life. He just knew that the way to solve these problems and to get these motions of the planets down better was you just had to measure everything better than it had ever been measured before. And so he became his task was to refine the positions of the stars and to track the planets and all that. Well, a supernova happens in 1572, and he sees it, and he documents it, and he publishes his finding and proves that it was a new star. Well, that was a big deal, because in a world in which the universe was immutable, a new star was ground shaking, cosmologically speaking. And this kicks off a new open mind. Now, you know, it kicks off a new interest in observational astronomy, and you can then track this and how it picks up steam over time, because it just opened the mind that once again it was worthwhile to study the night sky. And one evidence of that is Uranometria, Johann Bayer's compilation of the 1,564 of the brightest stars, and they're making a atlas, sky atlas, star atlas, in 1603, I believe. I did fail to put that on here, so I wouldn't need a note. But 1603, he creates this atlas, and he uses Tycho's data that Tycho had compiled, Ptolemy's constellations, and some other sources to come up with his 1,500. And he, as everybody in here probably knows, he's the originator of the Greek alphabet naming system that still is prominent in naming stars today, where you use a Greek letter in the constellation the star is in, usually alpha being the brightest and going down through the Greek alphabet. He's the originator of that. In his original work, he goes on down into the Roman alphabet some too. That doesn't get used much anymore. Well, why is this showing interest? Well, there are still 100 copies of this of the original printing of this still in existence. Now, if there was 100 copies of them still in existence, how many were originally printed? A goodly number. And then there were 4 more editions after this. And how many professional astronomers were there in the world, you think, back then? These were amateurs buying these sky watchers like us in this room who were buying these charts. And lo and behold, what happens? Well, the very first variable star, besides supernovas, discovered, and setting aside Algol, which seems to have been documented back by the Egyptians 4 or 5 millennia back from here, is discovered by a German preacher, an amateur sky watcher. And in 1596, he sees Mira where he does not expect to see a star. And he just writes it off as another supernova, like Tycho's, right? Well, jump forward to 1609. Now, the telescope was invented in 1608. Galileo turns it on the sky famously in 1609 and sees, of course, the church's view, the prevailing view was the moon was this polished orb, this pearl in the sky, celestial perfection. He puts the telescope on it. Hell, it's a terrestrial body. And he turns on Saturn and he sees it's got moons. And he realizes it's just a planet. Earth is a planet. So these are eye-opening event happening, but that's sort of a diversion here. But because David Fabricus here, who viewed Mira in 1596, he's got a telescope in 1609. 1 year after it's invented, he's got a telescope, and he sees Mira in that telescope when it's not visible to the naked eye. And he realizes that that star is variable. So that's the first one. I got some notes down here. Johannes Holloward, we'll run into him again in a minute. He figures out that Mira has got an 11-year cycle in 1638. Algol is rediscovered by Western science in 1669. CAAS Cygnus is discovered in 1686. R Hydra in 1704. And by 1786, there are 10 variable stars known. And the pace of discovery is getting ready to explode. Now, we all know William Herschel and his sister, Carolyn, probably the ultimate amateur astronomers of all time, arduous recorders of sky objects of all sorts. Well, his son, Sir John Herschel, followed in his footsteps, made a career of astronomy. And he publishes in 1833 an edition, a treatise on astronomy. And in it, he says, this is a branch of practical astronomy that has been too little followed up, and is precisely that in which amateurs of the science, provided only good eyes or a modest instruments, might employ time to excellent advantage. And I'll just say right now, it's still true. A pair of good eyes or a pair of binoculars or a modest instrument, and you can still do variable star observing and contribute it to the science body of science and be credited for it, as we will see. So he encourages this. Once again, I'm just going to use charts for Mira in all of this. You go on to the AAVSO, the American Association of Variable Star Observers, that we're going to talk about the birth of here in a little bit, which is fundamentally an origin, an amateur organization, and it's still, they say they bring amateurs and professionals together. uh, they record all this data from that they can gather from way back when. And if you go out tonight and were to observe a variable star and turn that in, it would go in their record and would go in their record under your name. And you can go in and research, pull up the star, pull up an observer, and see the data that exists from, as I say, for a given star over a given period of time, or from a given observer. And this is the star that Probicus first sees in 1596, Mira. And here are his observations here, and then later with a telescope there. Then I mentioned to you Halwarda, who figures out the period. Here are his observations. And then I just grabbed this guy, Johannes Hevelius, because he was sort of the next and observed it over about a period of 30 years, arduously observing Mira and probably other stars as well. And you can see, you just come down here and click on his observer code is HVJ. He's got 152 observations in this time frame of this star. Now, he's most noted because he first did an atlas of the moon. He charted a moon in the 17th century. He was the mayor of Danzig, another amateur. And those charts of the moon were the first published. They published after his death. But you can see all this going on. And then, I don't know why this gap is here. That would be an interesting little historical deal. But you can see that Sir John Herschel calls for more amateur involvement in variable star observation. And when the record picks up again, you can see it's a whole lot different than it was, much denser. Now, a German astronomer, Arlinger, I don't know why I'm suddenly drawing a problem with that. He comes along, he's really sort of the dean of variable star observing, to tell you the truth. And he invents the scheme by which we name variable stars. He makes another call to amateurs to become involved in 1844. But it's Edward Pickering that really sets the ball rolling for the what leads to the American Association of Variable Star Observers. He was the director of the Harvard Observatory, and he was obviously very interested in the variable stars, understanding how important understanding them could be to advancing astronomy. And he also realized there were a hell of a lot more variable stars than there were professional astronomers. He needed data, and their stars were out there. What to do? Well, he publishes a plan for securing observations of variable stars. And he basically says to, like Herschel and Arlinger, I know I'm pronouncing that wrong, before him, calls for amateurs to become involved in observing stars, but he does one thing more. He says, send the data to me. Send the data to me, and I'll collect this data. We'll catalog, we'll archive this data, and I can analyze it. And so he kicks this ball off in 1882. And so you just come in here, and I should have gone a little longer than 1907, because his project goes on until it gets actually taken over by somebody else in 1911. But you can see, again, this is just Mira. The observations that are now in the record that were gathered during this time frame after he had made his appeal. Now, in this case, I just picked out Thomas Blackhouse here, Thomas Blackhouse, and I did it because he had so many observations. And I say, Google it. That's what I did with these other guys too, by the way. Google Thomas Blackhouse. Well, up comes an obituary notice from the Royal Astronomy Society in Britain announcing that he's passed away, and it describes his activities a little bit. He had a 4.25-inch Cook refractor in a personal observatory in his home place, and I forget how many observations they credited him with over years. But my point is that if he were here tonight and you could talk to him, it would be the same kind of conversation that any of us have about his telescope and what it does and what it doesn't do and what he does with it and so forth. A kindred spirit. And here he is, his data eternally here, and also noted, as I say, in his obituary. Now, in that picture, I couldn't show you all the observers, but up through 1907, there were 56 individuals contributing to that data, and altogether there was 3,581 observations of just Mira. So you can see how successful, and the bulk of these people are going to be amateurs. And just another example, David Flannery. Flannery's an Irishman. He immigrates to the United States in 1845, takes up a residence in Jackson, Mississippi. And then in 1895, he gets the bug, variable star bug. He makes 44,000 observations of 80 stars in the next 5 years of his life. And his little note, and here it is, recorded right here of Mira. And in his little notebook, he notes that he's basically not supposed to be out of bed. He's on his deathbed, but he sneaks down to a few steps, a few flights of a few step levels, so he can look out the window at his favorite variable star, which I can't remember which one it is right now. But I point that out because if you start doing this, and you don't have to give up anything else you're doing, you just add a variable star or two to your observing program and start recording them and turning them in. And over time, you get to know that star and its comparison stars. We'll talk about how this is done, that you use to judge its magnitude. You get to know those. And when you go to look at it, it's like you're going to see an old friend, and you're curious to catch up on what SS Cygni or whatever it is doing tonight. And that's what he was evidencing. Now, Pickering, now remember, he called for this in 1882. In 1891, he decided, boy, I'm going to help these guys out. We need more data. We need more amateurs, and to make it, we need to make it simpler. And so what he did, he started providing sequences. Well, sequences is nothing more than the list of stars that you use to judge the magnitude, and we'll talk about how that happens in a minute. So he started sending out, if you wanted to observe a certain star, he'd send you the sequence of comparison stars to use for that. And then in 1906, he decides to do even better than that, and he starts creating these charts. Now, this is still the way it's done today if you do variable work. But when I first did my variable star observing back in 1991, I believe it was, you had to, I believe you sent in a self-addressed stamped envelope and told them what charts you wanted, and they would mail you the charts. Well, of course, you don't do that anymore. Huh? Yeah, maybe you did. I don't really recall. And then you would record your things on paper. You know, you'd record your things on paper and mail them back in. But basically, you've got these stars with numbers beside them are your comparison stars. And this is your variable you're trying to study. And this star 103 is a 10.3 magnitude star. You just take the decimal, put the decimal point in there. They have obviously had to take the decimal point out because otherwise they'd look like a star, right? So there are no decimal points, but this is 10th magnitude. That's 10.3, 6.1, 4.8, 9.0, etc. and you just get your variable and you say, well, it's brighter than that one, it's dimmer than this one, and you work until you get it bracketed between two stars, if it's brighter than one and dimmer than the other. And then you say, well, okay, is it halfway between? Is it 3/4 of the way between? And so forth. That's how it works. And you'd be surprised how accurate that can be made when multiple observations are turned in by different people. You do a statistical kind of averaging on it, and they get tremendously accurate results. Now, so William Tyler Alcott, this got to where it was overwhelming Pickering. I think he took in like 6,000 observations from the time he made those charts available in 06 to 9/11. And he was being overwhelmed with the process of getting these things out and recording the data and everything. And one of his observers, William Tyler Alcott, volunteered to take that process off his hands. And he wrote into the Popular Astronomy that he would correspond with anybody that was interested in observing variable stars. And that basically is the beginning of the American Association of Variable Star Observers. All right. So today, you take Mira and you look at it, and there are 92,000 observations on record from 2,400 observers, and people are still turning in observations. Now you see the color here on the end. That's where digital stuff starts coming in, various kinds of digital photometry. But that does not mean you shouldn't do visual observing. They still want visual observations. Visual observations still value, and they help to maintain the continuity of the record over time. And you can see how dense these records have become. Now, today, the AAVSO is the depository for variable star data. I don't think there is another serious depository out there. At the moment, they've recorded, as of about a week or so ago when I was working on this, 64 million observations. Some of those these days are coming from the automated surveys. You know, they're pouring data in. I'll touch on that in a minute. They've got about 900 active observers, most of whom are going to be amateurs, turning in data. Now, so that's the sort of the AAVSO story. What I want to do is, you all know I'm a lawyer, I'm not a geeky guy, and yet I can do this. So if I can do it, you can do it. Anybody in here that can do the Messier list can start observing variable stars. And anybody in here who can make these beautiful photographs that people make could do photometry. It's in fact a lot easier. But I just want to touch on my personal activity here so you can see that this is approachable to you. This is from my first 2 years when I was doing visual work before I dropped out of the hobby for a time, which is another story. Diversion from here we don't get into. To tell you the truth, if I had some open sky in my back of my yard, I'd still be doing the visual in addition to what I'm doing photometrically, but I'd still be doing the visual. It's just a lot more rewarding. Like I said a while ago, you get to know these stars, and you get to where you can just put the telescope right on it. And then there's that friendly field of view that you know well, and you can make your estimate. You're doing it with your eyeballs, and you're out under the sky. It's a whole lot more fun than processing this data. But at any rate, this is a 2-year time period basically, and this is other people's data mostly, but mine, if you can make it out, are the little blue specks in here. And it's most satisfying to see that it fits right in with everybody else's data pretty well. And that's the other fun thing about this. When you turn in, then you get to go look at your data and see it. So you go on the website just to familiarize you a little bit with how easy this is. First of all, they've got this tab, new observers start here. You can't beat that. You ask for a code, they give you a code. I don't think you have to be a member. You didn't used to have to do. They got all this how-to information over here on all kinds of different ways of observing and different kinds of observation processes. They've got a thing here on what you should observe. And then this is the meat of the nut up here. This is where you click on that to turn your observations in these days. It's all done digitally, of course, online. This is a catalog of variable stars. Essentially every variable star is known to exist is now in that catalog. I'm trying to remember how many thousands, tens of thousands of stars. I think it's, I want to hazard a guess, but let's put it this way. The new general catalog of variable stars is 60,000, and it's a tiny little thing compared to the AVSO's catalog now, which is run by one professional and 10 volunteers, as I understand it. And the VSX, that's what I was just talking about. This is a program where you can either your data or somebody else's data that you can download off the site. You can plug it in here and do statistical analysis on it. I've actually been able to do some of that. I made a C in statistics in college. So it's pretty simple to run. This is where you get your charts. This is where you can process photometry, including done with DSLR cameras. And then this is where you can see the data like I've been showing you. Yes, sir. Well, I don't know for sure what that answer is, but I'll show you something in a minute that'll sort of answer it. Okay, I think. All right, this is just a typical chart of what this looks like. I've already showed you the ones when they were hand drawn them back in 1911. They were hand drawn them. They're obviously computer generated now, but it's the same kind of. This is a sequence. So each of these comparison stars has got a name and the right ascension declination, the label magnitude, and the actual V and B minus V color of the star. Just a picture that shows how a variable star can change in the way it might look. This is how you enter your observations. And then, like I say, once you do that, you can come back here and look and see your own observations. Now, I think this is going to answer your question. So when I got back into the hobby, I determined that I was going to get back in the variable star business, and I was going to get this robotic system set up, and I was going to do photometry. This is the first star. This is the first. I ran a time series on a cataclysmic variable. This is 6 hours. It's about 6 hours of data. So I think you were asking me how fast can it vary? And this is over a course of 6 hours. You've gone from almost 10.9 down to 10.5. So 4/10 of a magnitude in 6 hours. It can be a lively activity sometimes. That's not typical. Now, so now I'm gonna brag a little bit, but again, in the interest of saying, hell, if I can do this, you can do it. In my photometry, I use a computer program to process the data, right? And then I do a little quality control thing that I've made up myself, and to look and make sure that the comparison stars are behaving themselves. That they, in fact, comparison stars are supposed to be stable. See, and occasionally I have found a comparison star that didn't look right. And this was fairly early on, I discovered this one, and it turned out to be an eclipsing binary. So now I'm in the VESX catalog as the discoverer of this, and that's a pretty heady deal. You go on there and James Bruce McMath, discovered of this eclipsing binary. Eclipsing binaries are pretty important and fairly rare objects, by the way, because you can use they allow you to actually calculate the mass and temperature and all these other factors of the star. And then in some other cases, I think I also discovered an Uxor, but that was a known variable. It just wasn't known what it was. And then in 4 or 5 cases, I've been able to turn in data to show that a star was not properly classified. And this is one of them. Now, this is something I won't really, I bring this up primarily to note this. This is the data on the same star as my data taken from the Northern Sky Variable Star Survey. So they've got these surveys going. You might say, why would I bother to do photometry? They've got these surveys going that survey the whole damn sky, a clip and a huge database of data. The problem is, once again, there are more stars and more data than there are people to process it. So this star's nature was already out there in this database from the Sky Survey, but nobody knew it and so this is another thing you can do. Maybe you're like me, you just got trees all over your him you can't observe. If you're interested, you can get in and access this data and start processing this. And some people do. All they do is process the data and discover the nature of or discover the variability of stars. Now, this is what it looks like this is for that V0353 LAC that I just showed you the data on. If you go into the VSX and look at it, then this is where you I get to see my name, submitted here on this date, and the supporting documentation is my phase plot and so forth. There's a couple other references down here. So that's heady. And then, even if you don't do anything like that, just turn in your data. People access that data. They give you a report every week. You get a report from the AVSO if someone accessed some of the data you generated. And so this is a report I got at some point. And people downloaded my data along with other people's data, undoubtedly, on these stars in a certain August 28th, 2015. This is from that old slideshow, okay, some years ago, so I didn't bother to update it. So now, in addition, there's a community. If you get into this, you want to get in, you can tap the community. They've got these forums on all kinds of different topics. Some of them just basic how to do this, but other issues. And I think you have to be a member to do this, but you can participate in the forums. They've got a mentoring program, and I will, of course, be happy to mentor anybody that's interested in doing this right here. And it's a highly varied area. You can go in here. I do pre-main sequence stars. That's what my interest is. But there are all kinds of variables, and you just pick out one area that you're interested in and start learning about it, pick you out some stars, start observing them, and turn them in. It's as simple as that. And as I say, anybody can do it, and it's rewarding. That's it. End of my slideshow. Well, sure. Hopefully, it'll be on Zoom. It'll be on our YouTube channel. Oh yeah, no, I can figure out a way to post that. Yeah. All right. Thanks.
to hang things like these nice plaques. That one has names on it. And there's been an idea about the astro photo of the year done by members and things like that. So if anybody has any suggestions about that or thoughts or comments, please catch up with me just after the club meeting here this evening. And thank you.
With new ideas, business, etc. Guys, and everyone, please remember the Dark Sky Festival coming up on last year, great.
Thanks for everybody for coming to CAAS, and we'll see you all next time.